Hello, boys and girls. It's Miss Evans again, back with another mini lesson. And today is Wednesday, September the 9th, 2020. Again, our AKS is NBT.1 and NBT.2 over decimals. Your learning target is I can explain the value of each digit as 10 times the value of the digit to its right. Again, we're focusing on whole numbers and decimals. I can explain the value of each digit as 1/10 of the value of the digit to its left, focusing on decimals and whole numbers. So using a place value chart, we're going to explain how the value of 5 changes in the number 55 and 55 hundredths. First, we want you to explain how the 5 in the ones place is different from the 5 in the tens place. And finally, in the tens place. Let's look at this model more closely. So again, our question wants us to evaluate the 5 in the ones place and how it compares to the 5 in the tens place, which is the next place value to the right, as well as compare the 5 in the ones place to the 5 in the tens place, which is the next place value to the left. Recall that anytime a number is in the ones place, it has a value of that many numbers times 1. So in this case, 5 in the ones place has a value of 5. And I want to compare it to the 5 in the tens place. In this case 5/10. Because I shifted from one place value to the right, I'm decreasing in value. Therefore, I know I divided my 5 wholes by 10. Or I divided it by 1/10, which gives me back my 5/10. So the 5 in the ones place is 1/10 or 10 times more than the 5 in the tens place. The 5 in the tens place is 10 times less or 1/10 less than the 5 in the ones place. Now let's compare the digit of the 5 in the ones place to the 5 in the tens place. The 5 in the tens place has a value, the 5 in the ones place has a value of 5. And I want to compare it to the 5 in the tens place. Well, 5 in the tens place has a value of 50. 10, 20, 30, 40, 50. Because I moved from right to left, that means I increased in value. And therefore, that means I multiplied times 10. So, the 50 is 10 times more than the 5 in the ones place. Or you can say the 5 in the ones place is 10 times less than the 5 or the 50 in the tens place. Let's look at our next example. Explain how the 5 in the tens place now is different from the 5 in the hundreds place, then the ones place, and finally the tens place. So again, we're going to compare the 5 in the tens place now, which looks like this, 5/10. And we're going to compare that now to the place value to the right, which is hundredths. Okay, the hundredths place. Because I went from left to right, that means I decreased in value. So I'm going to be dividing by 10, or I'm going to be dividing by 1/10. So that means that this 5 in the hundredths place is 10 times or 1/10 less than the 5 in the tens place. So in this scenario, because we decreased in value, I'm going to represent that color in red. So we divided or decreased by 10. Now we're going to compare the same 5/10 to the place value to its left, meaning the 5 in the ones place. This 5 in the ones place means I have increased in value. Therefore, the 5 in the tens place is going to be multiplied by 10, or it's going to increase by 10 times. So I'm going to represent this color in green. So because we move from right to left, I'm going to be increasing by 10. Perfect. Now we're going to compare this 5 in the tens place to 2 place values over, or by 2 powers of 10s over. So we're going to be again increasing. So that means multiplication. Now we have to count by how many powers? To the left is by 1 power of 10, which is 10, and by 2 powers of 10, which is 100. Do you see any pattern in these numbers? Do you see any patterns in these numbers? 0.05 times 10 equals 0.5. 0.05 times 100 equals 5. 0.05 times 1,000 equals 50. What pattern do you see? Pause the video and think for a minute. I hope you were able to say that in the base 10 number system, digits to the left are 10 times as great as digits to the right. Likewise, digits to the right are 10 times less, or 1/10 less than the value of the digit to the left. That means we're dividing by 10. Here's our next example. We're going to use the place value chart to explain the value of the 7 and how it changes in the numbers 77 and 7700. First, let's explain how the 7 in the tens place is different from the 7 in the ones place and tens place. Then we're going to explain how the 7 in the hundredths place is different from the 7 in the tenths place, ones place, and tens place. Let's use our place value chart now. Alright, so again, we're going to look at example 1, the 7 in the tenths place in comparison to the 7 in the ones place and the 7 in the tenths place. So if we start here in the tenths place and I compare it to the 7 in the ones place, I have just moved from right to left. That means I am increasing times 10. When I go from the tenths place to the 7 in the tens place, I am increasing by 2 powers of 10. 10 and then 100. In our example 2, we want to now look at the 7 in the hundredths place and compare it to the 7 in the tenths place. Because I move from right to left, just 1 place, or 1 power of 10, I'm increasing by 10. When I take that 7 in the hundredths place and move to the left, I'm increasing in value. I move 1 power of 10, 2 power of 10. So that is times 100. When I go from the 7 in the hundredths place to the 7 in the tens place, I'm increasing in value, and I move from 1 power of 10, which is 10, 2 powers of 10, which is 100, and now 3 powers of 10, which is 1,000. Do you see any patterns in these numbers? 0.07 times 10 equals 0.7. 0.07 times 100 equals 7. 0.07 times 1,000 equals 70. I hope you noticed the digits to the left are 10 times as great as the digits to the right. Likewise, the digits to the right are 10 times less, or 1/10, or we divide it by 10, from the values of the digits to the left. Thank you for watching another mini lesson from Ms. Evans. I'll see you all tomorrow. Happy learning.